Hi, welcome to Digital Dialogs, your compact conversations on the future of technology. My name is Renee from Reply, and today we're going to talk about embodied AI, which is the next frontier with humanoid robots. And for this, I'm honored to have no one else than Will Jackson. Hi, Will. How are you today?
Yeah, hi, Renee. Good, thank you. It's an exciting time to be working on humanoid robots for sure.
Yes, and I would love to dive deeper into this. But before we do this, please introduce yourself and your background as it relates to research, education, robotics, all the great things. Of course, all your background.
Okay, yeah. So I'm currently the CEO and also the founder of Engineered Arts. Engineered Arts is a robotics company based in the UK. We founded back in 2004. My background before that, so I studied three-dimensional design, but I've always been a coder and a maker. So I actually built my first robot when I was about 14 years old. I taught myself to code assembler around the same time. And so I've kind of been building robots all 40 odd years now. So in between, I worked in advertising for a while and special effects, a lot of different design and make disciplines.
Awesome. And we will talk about the stuff you're building at Engineered Arts, but yeah, very much impressive. I also like the note you mentioned about that you taught yourself assembler. I also did that actually, but I also taught myself assembler back in the days. I started with the Ameca, Commodore Ameca 500. So it was good times for sure.
Yeah, I started with an Acorn Atom, which is an early 6502 system, and it only had 512 bytes of memory. So I didn't like using the assembler mnemonics, which were 3 characters each. So I taught myself to memorize the hex code for all of the assembler instructions, and I used to just code in hex. Insane. I don't know how I did it, but my programs actually used to run.
Yeah, it's what I think Bill Gates once said, like you only need 640 kilobyte of memory or something like this, which was funny enough, right? And but that's also what I enjoy about these older systems is you had very strong constraints with these kind of things, and it taught you to very much optimize also your code and to work inside of these constraints, which I sometimes really appreciate. Because these days, sometimes folks just assume, oh, things just magically work, and there's hardware that just makes these things magically work. And, it's like this kind of is missing sometimes.
Yeah, especially as we're now in the age of machine learning, computer vision, large language models. I often say to our software team, please don't use a large language model when an if-then statement will do the same trick, So you be efficient with your code. The whole experience with robots is if you have big latency for social interactions, that's a big problem. So we're always trying to work fast.
Yeah, definitely. And that's a good segue into the first real question, if you will, around one of the products you're building at Engineered Arts, the Ameca robot. And so how has the development of Ameca pushed the boundaries of what humanoid robots can achieve in terms of realism and interaction? And how do you think does Ameca's approach to embodied AI differ from other humanoid robots?
Yeah, okay. So that's quite a wide-ranging question. We first started on Ameca back in during pandemic because a lot of our regular business was closed down because we were making robots for public venues, for social interaction, large crowds of people, and all those venues closed down. So we decided to focus on just pure R&D, and Ameca came out of that. So just at the end of pandemic, going into 2022, we launched it at CES, and it was a much bigger success than we anticipated. I remember uploading just a short video, and I looked at it as I was leaving the office, and there were like 5,000 views, and I thought, oh, that's pretty good. And then I got home, and it was like 50,000 views. And I thought, wow, my commute is only 20 minutes, so something's happening here. And it just really struck a chord. And in the end, that ended up, I think, 50 million views or something on TikTok. It was crazy. And we realized that we'd made something that really resonated with people. It really connected in some way. And it was the emotion. It was the kind of emulation of human communication, not just speech. In fact, the first video we put out didn't have any speech at all. It was just expressions and gestures. So that connection was really, really powerful.
Yeah, that definitely. And I just noticed I always pronounce Ameca wrong. I pronounce it like Ameca. Maybe that's coming back to the initial thing. Maybe that's stuck in the brain.
Ameca's okay because we actually got the name is from the Latin for friend, as kind of a corruption of that, which would be Ameca. But that's also a brand that's been used by a few other companies. So we had a problem that we needed to change the spelling and the pronunciation a little bit. So in fact, you're more correct, but we had to change it. It turns out that Ameca is actually a region in South America, which we didn't realize at the time. But that's where it comes from.
Yeah, that's okay. So let's call our Ameca. And so what impressed me the first time I saw Ameca was really the all the details with the facial expressions and all the motors that are in the face. So maybe you can talk a little bit about the technical details there. What's happening with all the micromotor movement. And folks, since this is a podcast, you probably have not. You might get a chance to watch a video. So just go to your favorite search engine and look for a video around Engineered Arts Ameca, and then you can see it in action. And I'm sure you will also be impressed with the facial expression. So how do you accomplish that?
Okay, so there's quite a few different levels here. So one of the first things is the quality of motion that you get from your actuators. So the servos that you use. So we don't use any off-the-shelf servos at all. So all of the servo drives are custom built, designed in-house. So you're looking for a particular quality of motion. You want very smooth curves. You don't want any kind of jerky motion. And then there's on top of that, you've then got mechanical layer. So whatever links your drive to the face itself. So within that, you're looking for very low friction. You're looking for backlash free. You don't want any lost motion. So there's a lot of precision engineering and design tricks that we use for ensuring the motion on the physical level. The skin itself, obviously, is super important. The skins we use are very, very soft. So it's 20 grade silicon rubber, but it can go down to 0.5 millimeter thick. So, thin creases around the eyelids, etc., are very, very thin. And then we have a lot of additional layers that we build into the silicon that interface it to the mechanics. So we actually spent about 4 years developing that system. That we're still working on it. We're still becoming masters of how to emulate these facial expressions. There's always more to do. At the moment, Ameca has, I think, 27 actuators in its face. There's a system we use that's widely used for encoding facial movements, as the facial action units, it's called. You can look that up on Wikipedia. And you'll see that there are over 40 facial action units that people are capable of. So we're not doing all of them. We pick on the ones that show the most. It's actually, there is nothing as compact as and as strong as human muscle, and there's nothing as thin and as tough as human skin. So you have this problem that what you're trying to move is actually has more resistance than a human face would have. And what we're trying to move it with is actually weaker. So you end up taking a lot of volume inside the robot's head just to do the actuation. I would say it's lucky that we have the power of Wi-Fi and networks within the robot, so we don't actually have to put the brain in the head. So we end up filling the head with mechanics to operate the face.
Gotcha. Well, and like I said, you already did a great job there. Also, especially considering, well, the short development time, like 4 years, right? If you consider all the other companies, they couldn't achieve it. And that speaks a lot when you're saying you build your own servo motors to drive it. And only with that, you can actually achieve it. And also the skin you mentioned, and also the eyes, actually, because we're doing a nice project where we're using Ameca, also for the eyes and the eye tracking and so on, for some simulation about real world scenarios. And I also see you put a lot of effort into the eyes to make them look very realistic.
Yeah. So one of the key things about eyes is the speed they move at. So human eyes can do, I think, up to about 900 degrees a second. Average is more like 400 or 500, I think, but they are the fastest muscle in the human body. So you really have to have fast motors for eyes, and that means also having very good attention to the lost motion or backlash in the system, is you don't want any wobble in that eye at all. So, getting that quality of motion is really important. Then how you control it is important too. So humans never slowly track their eyes from left to right. Maybe if you're looking at an object, if you do it, so try this, try just moving your eyes slowly from left to right without looking at anything. You just cannot do it. So your eyes tend to fix on a certain point of interest in the image, and then they'll jump to another point. So if you watch somebody reading a line of text, you won't see their eyes move smoothly along. It's jump, jump, jump. Imitating those kind of human eye saccades, so the way that human eyes move, that's super important if you want to get realistic eye motion. Human eyelids as well. So if you look at your upper eyelid or watch somebody else and get them to look up and down, and you'll see that the upper lid of the eye tracks very, very closely with the iris. Okay, it's always just on the edge of that iris, except when you blink. These kind of behaviors we build in the kind of reflex level of Ameca. So if you're controlling Ameca with some of your own code, and you tell it to look down, look up, you'll notice that the eyelids always track with the eyes. So you get this very human-like behavior. These details are really important.
Yep. And I would definitely appreciate that you put so much effort into the details, because it's very useful, because we're using it for a simulation of a driver monitoring system, and we can simulate a human with it, basically, right? Because it's so good also when it comes to the eye tracking, the reflection, the corneal effect, and so on, the reflection in the eye, which is used by eye tracking system, right? You can simulate it also really well, although obviously if you look at the skin color, it's not a humanoid skin color. I guess you actually choosing this artificial blue color for a reason, right?
Yeah, so with Ameca, we wanted to make something that was very definitely a robot. We didn't want to have any chance that you confuse it with a person. So we went for a color, like we thought, what color would a person never be? Unless they were very, very ill, they would never be this color. So we went for this gray color. So we didn't want to be black, we didn't want to be white, we didn't want to look Asian, we didn't want to look any particular ethnicity. So we picked this gray color. And we tried to do a similar thing with the gender, that we wanted the look of the robot to be as gender neutral as possible. I think it actually leans a bit more towards female, most people say, but the intention was to try and come up with something that was pretty neutral in the middle. We wanted a blank canvas for people to project their own idea onto. We didn't want to present a strong character in any way.
Yeah, and definitely well done. And I think exactly the points you just made are in place when you look at Ameca. So yeah, very, very well done. Let's talk a little bit about the humanoid robots in general. So we can kind of categorize humanoid robots for two different use cases, if you will. So you have those that are like execution oriented, like more task oriented, if you will. Robotic systems like Boss Dynamics, Atlas, Tesla, Bot, Unitree H1, all of these, right? Like that are more focused to do a certain task and to basically merge into the world we have, which is built for humans, right? So we need systems that also can live and act in a world that is built for humans, because we cannot redesign everything in the end. We have these task execution oriented ones. Sorry, go ahead.
Yeah. So this is a very interesting thing for me. So how many, if you go to Boston Dynamics and ask them to buy a humanoid robot, what do you think the answer is?
Nope.
No. If you go to pretty much any humanoid robot company and ask them to buy a humanoid robot, the answer is no, because none of the systems are actually at a level of functionality where they're a product. None of them are products yet. Then comes the big question is, when do they become products? They become products when they meet, start to get towards human comparable. And I would say at the minute, if we're looking at things like dexterous manipulation, we're about 5%. And if you can see some fantastic, parkour, acrobatics, etc., performed by Boston Dynamics, the previous generation of Atlas, the new generation. So nobody's seen it do much yet, but I'm sure it's going to be good. Is a legged robot really necessary for utility tasks? Like if you walk into any factory, okay, you'll see things like conveyor belts. If you want to get something from one end of a factory to another end of a factory, there's a simple way of doing it. Now, there's always this argument that comes back, well, if I had a general purpose robot, then it just does everything. Well, you're making a wild assumption there. You're saying we can achieve human equivalence, okay? Nobody has even got close to human equivalence. There is no actuator known on planet Earth that can match biological muscle. We do not have it. Now, incremental changes to motor technology, to hydraulics, to pneumatics do not achieve human equivalence. So just point blank, with the technology we have today, a general purpose robot that's human equivalent is not happening. Forget it. Okay. Now there's an awful lot of money being pumped into this. There are some VCs who are going to get very badly burned, in my estimation, unless somebody comes up with, and they may, somebody may solve this problem. But a lot of smart people have been trying for a large number of years, myself included, and I haven't seen anybody who's done it yet, But so this is the big problem. It's actuation. We need something with very, very high force fidelity, very high transparency, very high power to weight ratio. And then if you look at the properties that we have, we're self-repairing. We can run for at least 50 years. We self-replicate. We have all these fantastic properties that no humanoid robot yet has. So this idea that, hey, if I just make a machine that does what humans do, I replace all the human labor, and bingo, I'm a billionaire. Okay, it looks great on the pitch deck presentation, but the big problem comes when you realize that what a humanoid robot can actually do is a tiny subset of what humans could do.
Yeah. No, definitely fully agree. So the grand challenge is to make the servo motors like a muscle, to basically get organic servo motors in the end, to make them as small and efficient and energy, the high energy density basically they have.
Yeah. So, and it's a very extreme challenge. And, I think we need a technical breakthrough it needs a completely different paradigm. So most of what you'll see in robot actuation today will be, brushless DC motors. Some robots tend to use a lot of strain wave gears or harmonic drives. That's a particularly bad idea, I think, for a humanoid robot because it's very low on compliance. It's too highly geared. The drive transparency is really poor. The force fidelity is poor. You can then start doing things to try and compensate for that, like adding active torque sensing or force sensing. Then you end up in complex feedback loops, which are not always stable or robust. You'll notice on a lot of quadrupeds now are using a thing we call a quasi-direct drive. So an electric motor on its own with no gearbox actually has really nice properties. It works pretty well, except that it's pretty rigid and it's way too heavy. So if we had an ungeared motor that's equivalent to a human muscle, it ends up just enormous. So you'll see some robots that have some very, I think one of Dennis Hong's robots, you'll see some very big motors in the hip, and that's an attempt to match human muscle properties by just having a very large motor. Now, it gets pretty impractical. You'll see it in MIT's Cheetah, I think it was. In that kind of robot, they use a small amount of gear reduction. So it gives you this trade-off, which is you're kind of getting a bit towards biological properties, just enough that you can make some things work, but it's really not equivalent.
Yeah. And so until we have all of this to build like fully task-oriented robots that can really live in a world built for humans, and we also have this other category for humanoid robots, which we would call interaction-oriented, which I would put Ameca under it, like where it's more about the interaction you're having. You might just have a bust or a head or whatever it is. It's clearly a robot, but you can already achieve some very cool interactions, also with strong emotional intelligence. So how do you see that aspect?
Yeah, so to me, the only reason to make a humanoid robot, to make a robot in human form, is human interaction. It's about interacting with people. It's about human-centric tasks. It's about social tasks. If you want to do something else like factory automation, you don't have to limit yourself to the human form. Why would you? Why be human when you could be superhuman? You could have 8 arms. You could fly. You could have wheels. There's all kinds of shortcuts and alternatives you could make if you don't need the human form as a constraint. Okay, so the only reason we constrain to the human form is because it's what's socially acceptable. It's what we are familiar with, and it feels natural for us. If we see this machine that moves in the way we do, has a similar form factor, then that's a really powerful reason. I always think about the first ever Star Wars film with C-3PO and R2-D2. So R2-D2 was the utility robot that kind of did everything, did these kind of functional tasks. It doesn't look like a person at all. It doesn't speak, doesn't have a face, it just does utility things. It's got a little gripper or whatever. C-3PO, in contrast, is the humanoid robot. Now, what was the vision for that? It was the translator. It was the robot that could speak every language in the universe and communicate with everybody and participate in conversations with humans and other species in the film. I think that was a really accurate vision from George Lucas, that the humanoid robot would be about human connection and the other robots can just be whatever shape they need to be, and that's fine. So I'm a little bit perplexed, really, when I see big valuations on these humanoid robot companies. I think, there's. I'm going to be either very surprised at what happens, or there's going to be a lot of money burned.
Yeah. I love the analogy you just made with the Star Wars movie, because I think, like you said, that actually the vision we have seen there is actually also what we're seeing the industry like moving towards too, right? We have these two categories, if you will. And Yeah, no, fantastic to always get some inspiration from sci-fi. But then in the end, a couple of decades later, it becomes real.
Yeah.
Um,
But this is I say this is true for many things in our technology, in our history. So it, when people say to me, "Oh, humanoid robots are not going to be important," I say, "Well, it doesn't matter that you say that because everybody else thinks otherwise." And the reason that you and I are talking over this video link on this flat screen TV was because that appeared in Flash Gordon in 1936. And Flash used to talk to people on this big screen via a video link. It wasn't because somebody at Skype invented it, it was because some kid grew up reading that comic. And you'll see the same thing with, why is Elon Musk making rockets? Why is Jeff Bezos making rockets? They grew up reading these comics, and that to them is the future. So we have this collective imagination that says the future is rockets, the future is flat screens, the future is flip phones, the future is humanoid robots, the future is flying cars, So we have all these ideas. So if you walk into the street and you stop anybody at random and say, tell me 3 things that you will see in the future that you don't see today. And they might tell you, a hover skateboard for sure, because I saw that in Back to the Future. And they'll say a humanoid robot, because I've seen that in lots of films. And then a spaceship, So these things will happen because we want them to. Whether they're a good idea or not doesn't really matter. We want them. That's what matters.
we want that, and it's going to happen. And also, when you spoke about the Musk and Bezos and so on, right? Boys will be boys.
I think it's not just that, but there is a bit of that. I think I think it's also about having a positive outlook on what the future can be. So we're looking, I prefer the vision of a technological utopia to rather than some sort of dystopian destruction. So I think humanoid robots can offer that. Now, of course, that can be twisted. People often look at what we're doing and say, oh my gosh, you're making Terminator and it's going to kill us all. I wouldn't worry about that.
And that's a good a point you're making, because we talked about Star Wars and the good kind of mindset. It kind of plants the seed, basically, right? But there's also other movies like Terminator, for example, that ruined perception of AI and robotic system for so many people. They just think these machines are going to kill us. Why should they? Like super intelligent AI, why should they care about humans? Why should they rather not care about exploring the universe, right? Because they can just easily replicate being electronic. And so that's my point of view, not so much of a doomer. And I think also in general, humans are good, and we will make sure that we build systems that are in a responsible manner and also will help humanity. And that's also what I'm seeing, and also what you said when you were talking about Ameca.
Yeah, for sure. So I believe, the vast majority, 99.9% of humans have a good intention. I always say the most dangerous thing is not AI, it's HS, which is human stupidity. There will be one dumb person who does, who lets off the nuclear bomb or does something. So we do have to have some kind of regulation. I do think AI is incredibly powerful. I think the opportunities for good are tremendous. They're enormous. But of course, we mustn't just unleash all of that power without any kind of regulation or framework.
That were some perfect closing words here, because I also fully agree with that. Like it's not black and white. It's not 0 and 1. It's kind of gray, and we have to navigate it all together with good alignment as a society. Well, thank you so much for joining us today, Will. That was great conversation, and also loved to hear all about the insights there. So yeah, thank you so much, Will, for your time today.
Great. Thank you, Renee. I look forward to working with you in the future on Ameca.
Great. And thanks everyone for joining us for Digital Dialogues, your compact conversations on technology. Watch our blog, follow our social media channels, subscribe to our Reply podcast channels to not miss the next episodes. And of course, you can always go to reply.com to listen to previous episodes or also to check out some of the other cool podcasts we're doing. Until then, take care and see you soon. Bye-bye.